We're now going to take a look at the sum, quotient, product, and difference functions with the functions being defined as with equations instead of ordered pairs. So let's take a look at what this really means when it says f plus g given those equations. It really just means this. It means f plus g of x, which means this. Take the f function and add it to the g function. Very straightforward. So let's take a look at picking the correct functions and putting them together. We have the f function here, that's the square root of x. The g function here, which is 2x minus 1, and we really can't do anything else with that. That's our resulting function. Okay, now the directions do say to state the domain of the new function. Now, I have a kind of a different way of working through this, so I'm going to recommend that when you're asked to state the domain and you're given the function in terms of x, that you draw a number line and you just kind of give it some, just a stylized number line with just negative area, 0, and the positive area. And my suggestion is this. Starting with the negative, ask yourself, is it okay to put a negative in all of the x positions? And of course it's not. It's okay on this one right here, but it's not okay on this one because we would end up with imaginary numbers, and that's not what we're talking about when we are asked about the domain. The domain is in the real realm of the number realm, and so we're going to put an x through the negative section of our number line. Okay, this is the real number line. So let's take a look at 0. Is 0 going to be okay to put in here and here and not break any math rules? Now when I say break any math rules, I mean, would it result in an imaginary number? No. Would it result in a 0 on the bottom of a fraction, meaning undefined? No. So it looks like that putting a 0 in, is going to be just fine. So I'm going to go ahead and check that. Then now I'm going to go to the positive side of the number line, and I'm going to ask the same question. Is it okay to put positive numbers, any positive number, in those x places? And yes, indeed it is okay to put any positive number. So I've discovered my domain, and that is this. My domain is starting at 0 and going to positive infinity. Pretty simple, right? 0 to infinity, and that's in interval notation. So let's go ahead and take a look at the next one. We have the g function divided by the f function, and that simply means take the g function, g of x, divide by the f function, f of x, and we'll see what we get. I'm going to move this out of the way. So we have the g function, which is 2x minus 1, divided by the f function, which is this. Now, I'm going to leave that radical on the bottom. I mean, we're not going to worry about the leaving irrational numbers on the bottom because we don't know that it's irrational, and so we don't need to necessarily rationalize because it is a variable. So we're going to go ahead and leave it there, and it also helps me to pick out my values, right, that are going to be okay for the domain. So here we go. There's negative, 0, and positive. So we're trying to find what will work as the input values for x. Is it okay to put in negative values? Is it okay for that to go in? And no, of course it's not okay because of this right here. So we're going to put an x through that part, same as before. And this time we're going to ask, is it okay to put a 0 in? Well, normally it would be okay. Up here it was okay, but here, because this is in the denominator, I can put it in because of the radical, but I can't put it in because it's in the denominator. So the square root of 0 is 0, and that's a 0 in the denominator. I'm not going to be able to use the 0 this time. I am going to be able to use positives if I think through that if I put any positive number in there, other than any positive number, then I'm going to be able to have a real answer, and I'm not going to be breaking any math rules. So my domain for this one ends up being very similar to the previous domain, but we cannot include 0 this time. Okay, we can't include the 0 this time because that would create a 0 on the bottom of the fraction. All right, let's take a look now at the g times the h function. G times the h. So the g function is this. The h function, let me remind you, the h function up here was x plus 2. Now, I'm going to go ahead and multiply these two together. Some of you call this foiling. I'm going to FOIL it. So we have 2x squared plus 3x, is that right? Minus 2, I think so. Let me double check my answer here. 2x squared plus 4x minus 1x. Okay, so this is my answer, and I'm looking at that. I'm going to bring my number line right over here. And you can already tell what the domain is going to be for this one because it's really simple. I don't have any denominator. I don't have any radicals. And so it's going to be fine to put in any value for x. This is a polynomial, and the domain for polynomials is negative infinity to infinity. Any value of x works. So that was quite simple. All right, the last one is going to be, let me move this down a little bit. Last one is going to be g minus h. Here we go. The g function, 2x minus 1. Now minus, again, if you watched the last video, you know that when I have a minus, when I'm subtracting a function from another function, if the function that I'm subtracting is a binomial or larger, then I'm going to have to use parentheses. So we have 2x minus 1 minus x minus 2. That's going to be, 2x minus x is x, and that's going to be minus 3. So there's my answer, and my domain this time is again going to be all real numbers. All right, thanks for watching.